81 is D. 80.
Wait, how do you know about the -1? I get the 1.
What?
I get the 1.
Go back.
Because f of x equals f of negative x.
I'll go over them. Let me give you the answers first, for heaven's sakes.
Okay, so 81 is.
81 is D.
Oh, okay.
82 is C.
Yeah.
83 is C.
Yeah.
Wait, we got a term. Oh, okay.
All right, yeah. All right.
84 is D.
Good. Okay.
85 is B.
Oh, I
80
remember you telling us that.
6 is B.
Okay.
Did we stop at 87?
No, we did 87.
We did 87.
Well, that's what I mean. 87 is the last one. Is B.
Yeah.
So there were four
We only
B's
got
in a
one
row.
wrong.
No.
Three.
There were 3 B's in a row.
Was
Why?
87? 87.
And later on in this test, if I were to give you the rest of the questions, which I did not, but 88, 89, and 90 are E, E, E. So it goes B, 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 E, E, E. That's mean.
That's really stressful.
It's randomized, supposedly. Okay.
Negative x, so you can assume
Just
something.
embody you.
F of x equals f of negative x. Why didn't I think about that? I didn't see it. Okay, it all makes sense now.
Okay.
Answers would just be flipped.
So on 81, since most of you groaned on 81,
I felt so good about that.
let f be a function that's twice differentiable, just means we can take the derivative twice, and satisfies the conditions in the above table. It says f of x equals f of negative x. Tell me what that means. What does,
They're just like inverses.
That means that everything
They're just
that's
like
on the positive
opposites.
side is also on the negative side.
okay, do you remember what this is called?
Even function.
This is an even function. It would be like a parabola.
No, no cap.
Okay, so it says, what are the x-coordinates of the points of inflection of the graph of f on -2 to 2? We're looking for what happens. What are we trying to find?
The second derivative changes.
Where the second derivative changes from positive to negative or negative to positive. But it's going to happen, if it happens at 1 where it changes, then it also has to happen at -1. So did you put B as your answer?
Yeah.
Then we just forgot
We
the.
just forgot that f of x equals f on.
You mean the details that they gave you?
That's probably
Random?
the only one I got right. But it's
I need to read the
Yo, Miss Allison, we gotta curve this because I'm garbage.
I feel better about this problem.
Stop.
Stop.
All right.
What?
No,
Are you? Does that remind you of something?
Oh, you just.
Yes.
Oh.
Oh.
82, do you want me to go over 82?
I've plugged
Yes?
it into the calculator 3 times and I can't get it right.
Okay.
Oh my god. I did.
Do you use integral over intervals?
No, there we go. I'm gonna read
Yep.
That's why.
Oh, I forgot about that in 7th grade though.
Okay, this would be integral over interval. So therefore, I would take the integral from 0 to pi over 2 of root cosine x. I would do no work by hand. Legit, nothing. Type it in your calculator. Don't touch it. Yes, okay.
He says legitly.
I don't know that that's an adverb. Okay,
What we said, and he said, "You make up words all the time."
that's fair enough.
I don't think he likes our class.
83, do you want me to go over 83?
We're all good.
It good on 83?
Yeah, that was my bad.
He called
yeah.
your class full of
84.
That's the show. What do you think to say?
No, that
You
makes
should explain this one.
Okay.
He didn't care how anyone did on the AP test if they got 1s or 2s. He didn't care.
Oh.
Let's go over 84. Can I show you how I would do it and let you type it in and see how it shows up for you? Okay, so this asks us to let function be f with a first derivative that's given. And it says, which of the following are intervals on which the graph f is concave down? What would we be looking for when we talk about f being concave down? We want f double prime to be less than 0. Okay? We were given f prime. So how do I get from f prime to f double prime? Take the derivative. So in y1, I am going to put this function I'm going to put that in y1, and in y2, what I'm going to tell my calculator to do is to take the derivative with respect to x of y1, where x equals x, and this is going to take forever to graph. So what you're going to want to do here is find where this function,
That's not the F function, that's the Because
I just like type in values for the graph and just like look at where y1 is negative.
Oh, sorry, I guess.
Could you also, you take the integral of that function and then graph the integral and then just like look at it?
yes, I mean, yes, you should be able to do that as well. So if you took the derivative function and then graphed it, the integral function, yeah, it should work. No. You know why it won't work? Is because we don't have an initial condition. So it wouldn't know where to start your graph. We don't have an initial condition, so that will not work. Yes, it would work if we had an initial condition. Good.
Yeah.
If you're in the graph window and you go second calc and you find your zeros, so if you go and find your zeros, you know, that's why they pay me the big bucks. Yeah, that's about right. Yeah,
Get it? Because teachers don't make any money.
I do get
They
it.
live on the poverty line.
Well, we're not quite there, but yes.
So let's
like
be
her
fair, we
pension
live
is pretty
in
good.
Highlands Ranch.
Okay, let's see. The fuel consumption of a car in miles per gallon is modeled by that function where S is the speed of the car, miles per hour. If the car is traveling 50 miles per hour and its speed is changing at the rate of 20 miles per hour squared. So then oops, I kind of don't want black or red. df dt.
This is related rates, right?
20 miles per hour squared.
We're looking for DFT.
You are correct. Sorry. I haven't done these ones yet. dsdt. The speed of the car is changing at a rate of 20 miles per hour squared. What is the rate at which the fuel consumption is changing? Correct. We are trying to find df dt is what we want to find. And the car is traveling at 50 miles per hour. So then S is 50 miles per hour. Yep. Okay. Oh, but the glorious thing is this is a calculator question.
Yeah, love calculating.
It's not that bad to do by hand, too. I mean, but like,
Don't do it by hand.
Don't do it by hand.
Calculator.
Okay.
Taylor, to be asked, I don't
I can't
remember.
remember asking.
She must have Alzheimer's because I don't remember asking.
Everybody's just talking to Taylor right now.
Jeez. So this would be 6e to
It's
the,
at 9 o'clock at night.
I guess.
Just making someone eat themselves.
Would that not be the definition of gaslighting?
Gaslighting isn't the
You're too
thing.
funny to like.
I think you made it up.
I did. I'm super good at
You're crazy.
because I need to then take the derivative of that. Yeah. So I would take the derivative of this, which the derivative of s over 20 would be 1/20th
Where are we doing this by hand?
ds dt. No.
Well, you're right. What you plug in.
Yeah, but that's the thing. I was trying to decide what I would plug in. Minus 2s over 2400. That's silly, but I wrote it. ds dt.
Why would you just have to do DSDT on the
Can you
whole
just
thing?
do the
You can.
derivative
Yes, you can.
of S times 20?
Oh, I see what you did.
Can you just do that? Because that's what I did, and I got the answer. No? It feels like so much work to do that.
It is. That would be times 20. That's exactly what she was saying.
Oh.
Because really, you could rewrite this as 6e to the s over 20 minus s squared over 2400 times the chain 1/20th minus 2s. I don't know why I'm writing 2s over 2400, but I did twice. Times ds dt. So yes, you could multiply the whole thing. So this is where this is f prime of s. I'm trying to think of how I would plug this in.
No, because I literally just did derivative of f of s times 20.
And that would be fine.
And that's all I did.
That would be fine. So if you type this in your calculator, what I would do is in y1, I would type in that f of s equation. In y2, I would take the derivative with respect to x of that equation of y1, evaluated when x equals, x is s, so s is 50. So evaluated when s is 50. But then what you would need to do is once you get this answer, multiply by the ds dt, which would be 20
That makes sense.
miles per hour squared. So if we were to do it by hand, that's what I would do. If we were to type it in our calculator, I would still type this in my calculator. Like if I were plugging it in, I would still plug the s in. I would do it all in my calculator at that point.
Miss Allison,
Yeah.
would you say like the conceptual
I don't
questions
remember.
kind of like
B.
B3 will most likely be in the not, or the
B.
calculator section?
I'd say you'd get a good mix of them in the non-calculator and
Okay.
calculator. Any others you want?
No, Miss Allison.
Okay, so let's look at 86. If f prime of 0 is
Logic to 86.
f prime of 0,
Logic it.
or sorry, f prime of x is greater than 0 for all numbers, and the integral from 7 to 4 is 0, which of the following could be a table of values from the function of f?
It can't be E
Because
because the
has to
area
be
has to be
negative.
0.
It couldn't be C and
It
D
has
because
to
they are
be
the function isn't increasing.
Some negative numbers and it can't be
And
A
it can't
because
be
the slope
B.
is because it's always has the area under the curve is always negative.
Yeah. So
Yeah.
it has to be B or C, but you would say
But C's decreasing.
yeah. So then
Yeah.
you would do B.
So it has to be B?
Yeah.
it does have to be b. Okay,
Yeah.
so the logic behind this, let's go over it again. It cannot be ey.
Because there's no
only
negative
positive.
slope, so you couldn't get 0. Like
No.
equal 0.
How do you know there's no negative slope?
No, not slope.
Ne-
It's
no
always,
negative area under
it's
the
always
curve.
greater, the area under the curve is always greater than 0.
Correct. The area under the curve would always be greater than 0 there.
And then that one.
A
C
is
and D
the
both have
opposite.
positive slopes.
Oh, so therefore it couldn't.
A is always positive area. Or no, only negative area.
Yeah.
That's what I
D
meant.
doesn't even have an
C
area.
and D are both.
But it could
Not
equal
Well, no, D
zero.
doesn't
Non-positive
work in that
slopes.
regard, but it doesn't have. You're right. It doesn't have a positive.
So it
slope.
has
It
to
has
be
Okay.
zeros.
So we need the slope to be greater than 0, so we need the slope to be positive. And if we looked at the slope here,
D is
Um,
D
zero.
doesn't.
C is negative at one point.
slope equals 0, and here the slope is both positive
The first positive, then negative.
and negative. Not at the same time, just at some point. So B would be my answer there. Good?
Oh, I see. Yeah, logic.
I like logic. I don't know how else you'd do that one. I think that's the best way to do it.
You graph it.
Okay, first quadrant, bound above by the graph of y equals the natural log of 3 minus x. So this looks like this. Something like that. For 0 to 2, I've got to shift the graph, sorry. Shifting it, flipping it, shifting it right 3, so it looks something like this.
There you go.
Okay, just need to get on the right side of the axis. I flipped it and didn't shift it. Okay. For R is the base of a solid for which each cross section perpendicular to the x-axis, so we're going this way, is a square. So we have a square that's like this, where my base is the difference between the height of the curve and 0. So this base right here would be the natural log of 3 minus x. And if we're trying to find the volume, first to find the volume, we'd need to find the area. So this would be the natural log of 3 minus x as well, because it's a square. And therefore, the area here would be the natural log of 3 minus x squared dx. And it's the integral from 0 to 2. And I would type that in my calculator. I would not do any work. Answer is B. Yeah? We good?